Welcome to this presentation on infection control from a facilities management perspective. We touch on infection control throughout several of the courses and through the HFL program. This issue is an issue that is only growing in focus and intensity, and it's expanding. ASHRAE 188, I believe, before too long is going to become pretty much the standard and law of the land, not just a document that can be adopted. And for those of you that know this, ASHRAE 188 is specific to waterborne pathogens, and it relates to an awful lot to infection prevention. More commonly, we speak and discuss about air and the way we manage air as it relates to infection prevention, and that's pretty much going to be the main focus of this presentation. But there's just a lot more to come. So I'm looking forward to looking at this. We're going to again try to raise awareness and continue to push the awareness of the effect and the impact as it relates to facilities management. This is something where I believe we have lots of opportunity. I don't know that we're really meeting the minimums when it comes to operations. I think we're doing a pretty good job when it comes to construction, and even there, I do believe we struggle. And in both areas, I think we're getting tired. I know that this has been going on for a few years, this extra focus, but we're really still at the beginning of this, and we have quite a long way to go, as you're probably becoming more and more aware for those of you who are working in the industry. So what is infection control? And this is really more specifically as it relates to operations. Well, it's the means, the methods, and the measures that we diligently plan for and execute to ensure that patients, staff, and visitors are not negatively affected by the routine maintenance and construction work we do. Two things I really want to point out here, and that is that we diligently plan. This is something that I think that when you deal with a reactive environment, as facilities often is, and it's really the nature of facilities because of the kind of work we do and the kind of environment we work in the midst of all of this chaos and organized chaos and putting out fires, we have to have a level of diligence. The other part is the routine maintenance. This is something that we're going to spend quite a bit of time talking about there in this presentation, and that is routine maintenance. Again, we've spent a lot of time talking about construction, but as stated in this definition, it's routine maintenance that we really need to continue to expand and work on infection control. So here are the objectives. Okay, understand the importance of infection control during construction. Know that it applies to facilities engineers, IT staff, and contractors. Talk about how to assess the risk associated with your projects. And we're going to discuss some of the special conditions and requirements for your construction sites specifically. For example, it may require bilingual needs. And for those of you that live in parts of the country that have a lot of bilingual challenges, or maybe trilingual challenges, this is a pretty serious issue. The necessary and correct behaviors of your staff and contractors, and again, we'll spend quite a bit, and I'll touch on this throughout the presentation. The types of construction projects. Well, infection control applies to all of the following. Routine facilities maintenance. Again, can't say that enough. Routine facilities maintenance. And code is catching up with this. More and more, we're seeing more code speaking specifically, not just to construction, but speaking to maintenance operations. Facility funded demo rental projects. Again, sometimes when we have projects that we fund and we're not necessarily actively involved in them, we're still responsible and it still applies. Corporate funded demo projects and rental projects applies to capital infrastructure projects. You know, very commonly we'll get small projects, or we'll get like a capital item that will require some kind of update, modernization, or change in our physical environment. And we don't think of them as being so big, so we sort of kind of slough them off as maybe not needing quite the same intensity of documentation and practices, when in fact it definitely applies to those as well. Again, we're seeing a lot of shift in code that's pretty much giving us this language that is looking for compliance at 100% levels. It's no longer kind of optional or sometimes or during just major stuff. It's coming down the line where it's like you must do this all the time, and that's a big challenge and shift in our thinking in facilities. So why is infection control important? Well, Recent data from 2015 or 2016 is that 750,000 patients that admit to hospitals acquire infections, and that's just a huge number. It's down from 1.2 million, but still, it's an enormous number. An estimated 76,000 patients of those that get them die, which is still an extraordinary number. And it estimated about 3,500, 3 to 4,000 really, or 3 to 5% of this number is attributed to construction and maintenance related activities. So again, this is newer data. We are doing better, but we do have a very long way to go. And understand too, it's not on this slide, but the cost is in the billions and billions of dollars from money that's not given back to us from Medicaid, Medicare, or possibly even insurers. Okay, so definition of nosocomial, again, a hospital, and really that needs to change. That's healthcare acquired infection, not hospital. I need to update this language here. But again, it's an infection whose development is favored by a hospital environment or healthcare environment, such as one acquired by a patient during a hospital visit or one developing among hospital staff. Such infections include fungal and bacterial infections and are aggravated by the reduced resistance of individual patients, and more specifically, patients that are immunocompromised. And we'll talk about that some more. Again, the percentage is 3.8% of the estimated 76,000 are related to construction, and to 5.5%. Okay, why infection control? Why is infection control important and continued? It's based on large sample of U.S. acute care hospitals. On any given day, 1 in 25 hospital patients has at least one healthcare associated infection. And again, these are the statistics that I talked about previously. In 2011, more specifically, 722,000 infections, and again, 75,000 patients died. And again, more than half occurred outside of the intensive care unit. Very important because we often attribute intensive care as being the primary place where infections are going to be, people are going to be most immunocompromised. And again, going to reinforce throughout this presentation that it is many other places, and one might even suggest it could be any place in a healthcare facility. And I'll touch on that some more as we carry through this presentation. Again, and here's some of the major infections and the estimated number of people that have gotten those type of infections. Know that pneumonia is the main infection that people get when they are related to construction and maintenance, because it has an awful lot to do with lungs and the type of things that people breathe into their lungs. Okay, at-risk patient population, and again, this is really not in any particular order. The common thread here is going to be that these patients basically are immunocompromised. Bone marrow, hematopoietic stem cell, solid organ, and lungs, heart, liver, kidney, transplant folks. And in the oncology world or the cancer world, leukemia and chemotherapy and radiation. We have burns, cystic fibrosis, COPD. Here's the list continues on. Diabetes, which is such a common illness, is something that there are different phases and stages of diabetes. I've known of several recent stories from people that I know who had loved ones acquire or die from infections in healthcare who had diabetes. They went with diabetes, which complicates their situation, make them more immunocompromised. Dialysis is also a very common element in healthcare. Tuberculosis, late-stage HIV and AIDS, premature infants, severe malnutrition and alcoholism, which was kind of a surprise for me. You don't really, severe malnutrition, yes, but alcoholism, you don't necessarily always relate that to immunocompromised. Surgical patients, obviously, and then chronic granulomatosis, something like that. Researched this a little bit, and pretty much it's immunocompromised children that typically don't live beyond the age of 10. The list before, when we looked at it, it was pretty obvious when it comes to cancer and bone marrow and heart and things like that. This list is not so obvious. And what this list really speaks to is probably the more serious nature of the potential of infections in areas outside of critical care areas. We certainly have an oncology area, certainly have a heart floor, or if you have a burn unit or something like that. it's easy for us to kind of, I think, really focus on those areas and say, you know what, we really better, apply our infection control practices. However, so a lot of patients, not only are they in lower acuity areas often, they are often, and you ready for this, they're often visitors. When you look at this list right here, you can imagine where quite a few folks on this list, diabetes, tuberculosis, maybe, um, even the surgical patients who may have just gotten out, or people with alcoholism, could be just walking in your facility. And there is kind of a weird expectation by the public. They really do believe that healthcare is cleaner. They believe that we are always maintaining a much cleaner environment. There is a lot of information suggesting that people who are healthy should not even come into hospitals because of the concentrated potential in hospitals. However, that's not the way people look at hospitals. I mean, maybe that's changing a little bit, but I think still people do believe that hospitals keep their areas much cleaner than normal places. Largely, I think that's true. However, I do believe that it's maybe not as clean as people think they are because of all the activities that are going on inside hospitals and the concentration of people in hospitals. I mean, one kind of a funny but strange story is we had a gentleman at my last hospital who would come to our hospital to get water and ice from our cafeteria for home because he believed that the water was cleaner at the hospital, that we actually use a lot more purification processes, and therefore it was better water than he could get anywhere. Kind of peculiar. And in fact, I knew that our water was fed from a well, and I knew that we struggled with maintaining the quality of our water in our hospital. And it was better than most, but certainly not as good as many places I've been. In other places. So we have an at-risk population. They do walk our corridors. They come visit. They are patients. And this makes this issue an even bigger issue. Construction and aspergillus. And I've been doing a presentation on construction and aspergillus where there was 40 years worth of data collected. And aspergillus is actually the most serious agent or the most common issue related to construction and maintenance activities. And I have a statistic here that says 60% of the people that do die due to maintenance and construction activities die because of aspergillus, and aspergillosis is the actual disease. And the amazing thing about this is that you cannot tell when the dust or the dirt, the biological, is going to cause an infection or not. By looking at it, you would never know. And it's very, very difficult and unfortunate that something that seems so common and so simple can be so serious to people. It's looking for, it's a spore that's looking for someplace moist to grow. And unfortunately, breathing it in and getting it into the lung is a perfect medium for growth and for it to create an illness. When you have a good immune system, your body will fight it off. You might even sneeze, or you might have drainage. I'm certain anybody that's worked in maintenance or facilities or construction has worked in an environment that's pretty dirty, and you end up getting a lot of drainage because of the irritation to your nasal passages and getting dust and dirt inside of you. Well, if you have a good immune system, that's not a big deal. However, if you severely immunocompromised, that again leads to potential of 60% deaths of all the deaths. And so this is one of those things where we disrupt airflow patterns all the time in our facilities, but through our maintenance and construction activities. And these things just move around. Not too long ago, my wife was making our bed, and she had this very specific kind of cover. I can't think of what kind of cover it was, but she was kind of like, she just washed it, as a matter of fact, and she was kind of putting it on the bed, and she was kind of flapping it in the air to get it to spread out. And after she did that, I looked up, and through a window that was up high in our room, I saw through the sunlight, I was amazed at how many pieces of lint, if you will, was coming off of that sheet, and how long it stayed suspended. And it certainly was countless. I mean, I was so shocked by it. I was just like, wow. And in fact, we ended up changing that cover out on our bed just because of just how much it was in the air. I mean, certainly we're breathing that into our lungs. So it's very easy to put into the air, and unfortunately, it's very easy to breathe in. The things that we do outside all the time, and we don't think about outside and the effects of what it does on the inside of our buildings. Groundbreaking, earth and tree work, utility installation, demolition, re-roofing and cladding, and paving road work, and it kicks up dust and dirt. And we often think, well, our best friend really is distance. There's a rule out there that you're not meant to do work within so many feet of intakes. It's easy to forget when we're doing work to assess where the intakes are. This is a common issue, particularly of those of you who are don't have a lot of property, or for that matter, you're kind of you're very densely built. These intakes sometimes can be in places you just don't recognize. You forget they're there. So exterior construction has to always be considered. You have to always look around, see the traffic patterns, the air patterns, maybe even the wind patterns when it comes to doing exterior construction. Interior construction, this is not an exhaustive list. This is just a partial list of all the interior construction potentials. I mean, floor and carpet repair, relocation activities, such a common thing that we do. And whenever we move stuff around, there's dirt that's been there maybe for decades because someone's been in that office for a long time. Building connection work, HVAC system utility upgrades, window replacements. I mean, IT/IS cable pulling, which is a common ongoing practice. Seems like that will go on forever. Equipment and lab hood installation, inspections. Water damage, response, and repair. Again, we do have lots of water issues in our buildings. Anyone that has worked at facilities for any amount of time has a story about some kind of a water damage issue or leak issue related to either specific, hot or cold water systems, domestic water. But very common, it's going to be related to air conditioning or backed up drains, things like that. That's going to create these messes for us. Mold, asbestos, and lead abatement. We'll talk about that some more a little bit later. But again, these are common issues, and there are so many more that can affect and create an infectious environment from a maintenance and construction perspective. Something else that we don't often think about is stack effect. This is a great diagram that shows how air movement changes seasonally. This is one of those things that our buildings breathe. They're living breathings. Our envelope breathes. Our buildings breathe. Those of you who have elevators or are very familiar with elevator operation, you have air dampers, at the top of your elevators, so it can release the pressure as the elevator goes up and down. Very often, those dampers get stuck, or they get rusted, and they don't open or don't close, and they stay open, which creates and accentuates the breathing issue as it relates to the building. But this diagram shows very specifically how in the winter you're going to have your building sort of air is going to be coming in from the bottom floor, and that hot air is going to be rising out of the top. And so you're going to have this airflow, this natural airflow that's going to be going from bottom to top. In the spring and the fall, it's kind of when it balances. It's not quite as aggressive. But we don't really have that kind of balance for very long. When we hit summer, again, it reverses. You start having air pushing out through the bottom, and cold air is falling. And so you get this movement out the other direction. And depending upon where you live around the country, you'll find that your stack effect is even more significant or less significant. The only other thing to point out with this drawing is that effect is magnified at the bottom and at the top of your buildings, depending upon how tall your building is. So basically, the taller your building, the more stack effect, versus the shorter your building, the less stack effect. So it's something that we don't often think about, but it definitely changes and has an impact on the way air flows in our buildings. It's another reason why we can spend a lot of time on our envelopes and our doors and things like that. So who regulates infection control around the construction and healthcare? The answer today, what we might say, well, it's the infection control team. We might say it's the infection control preventionist. But at the end of the day, truly, it is the facility manager. The facility manager regulates it. If that facility manager or that facility supervisor, and I'm really talking about the owner, facility manager, supervisor. I'm not talking about the construction superintendent. I'm talking about that person that is the intermediary, typically between the staff and upper management. I like to say, staff help regulate this, but candidly, I don't think that's a fair expectation. I mean, I think it's an expectation we need to have, but at the exact same time, it's the management that has to enforce compliance. and they have to do something. It's not enough to say, we fill out these forms and we make sure things get done. You have to actually enforce. You have to go out there. You have to be willing to shut a project down. You have to be willing to take a supervisor of a construction or maintenance person aside and talk about the importance of the value. Of course, I think this issue is so big, you're going to have backing. But too many times, I think that we see infection control and prevention as something that just gets in the way, slows us down, and causes us to have to delay in getting a job done. And that's all true. It is that. But we have to put it in perspective and context in terms of the fact that we're trying to go back to these enormous numbers that are still happening in healthcare, and we're trying to improve processes, not just barely or even fall short of the minimum. So it is really the facility supervisor or manager. We're the ones that really enforce and regulate this at the end of the day. The Joint Commission actually has some code. I know that some folks are surveyed by some of the others, but the Joint Commission is still the largest accreditation organization in the country. Their mission statement is to continuously improve healthcare for the public in collaboration with other stakeholders by evaluating healthcare organizations and inspiring them to excel in providing safe and effective care of the highest quality and value. The Joint Commission accredits approximately 16,000 healthcare organizations. I think this is actually down to about 15,000 with some of the growth of the other healthcare organizations, but still, it is the largest and it's a big number. Their accreditation, of course, accreditation is tied directly to Medicaid, Medicare dollars and reimbursements, which is the majority of reimbursements for nearly all healthcare facilities. Well, the Joint Commission also developed some standards that directly relate to healthcare construction and also the FGI guidelines. 2014, I have that notated here. That's really one of the most commonly adopted guidelines at this time. I believe 2010 may still be the specific one that's adopted by CMS and the Joint Commission. I think they're actually using 2014 right now, but this is a sliding scale. It changes around the country. And in the Joint Commission standards, EC 02, 06, 05, EP1, this has stayed fairly consistent. There's language, and that language is when planning for demolition, construction, or renovation, the hospital must, very strong, must conduct a pre-construction infection control risk assessment and or a project-specific ICRA. And those plans must be for air quality, infection control, utility requirements and shutdowns, noise and vibration, end-of-life safety measures, other hazards, and then again points back to EC 206, 05, EP2. Now, again, when you look at this, it says demolition, construction, and renovation. But believe me, this is expanding, and it's not going to be long before this language is going to be very specific to maintenance operations. But they could be applied. Again, this is all done so that we don't adversely affect healthcare, treatment, and services to patients, employees, or, and this is the key thing, the general public. I mentioned that earlier, and I think this is going to be the constant thread coming back at us. And let's not lose sight of employees. There's no doubt in my mind there are many, many employees that work in healthcare that are immunocompromised. You can even make a case for that some people actually enter healthcare because they're immunocompromised. They've been affected by an illness or a disease, and they want to, they've worked around healthcare or act as patients. They've lived with healthcare in their life, and it leads them to work in healthcare. So it's very possible you may have people who are immunocompromised. I know for a fact that I have had people who are immunocompromised working in healthcare. And again, as people work in healthcare for decades and age in healthcare, it's really very common for folks to become immunocompromised as employees as they get later in life. And as we've talked about, the general population in healthcare is older, and therefore the potential risk is going up. It has additional requirements, again, related, fire safety procedures during construction as specified in Life Safety 01, 02, 01. Again, the hospital protects occupants during periods of construction. In 01, 02, 01 EP2, the hospital posts signage identifying the location of alternative exits. And 01, 02, 01 EP3, the hospital has a written interim life safety measure. I can't begin to tell you how much more specific the language is becoming from CMS and the survey accreditation organizations on ILSMs and compliance. In fact, language in recent days or years has to do with people doing a inner life safety measure immediately upon identifying a problem, and immediately has been identified as in the same day plus one shift. And if you don't do that, you have to do an ILSM. This has absolutely pushed the need for ILSMs to be understood by everybody in facilities management, not just the supervisor, manager, and the director, to maintain compliance. So it's becoming again, the requirements are becoming very, very tight. They're telling us we need to learn how to manage our environments, in a very live, real-time way. They don't want us putting off things, or if something is not working, they don't want us delaying repairing it. Otherwise, we're going to have to do a lot more work. So before starting a project, what you need to think about? Well, first, you really got to know the scope of the project. How big is it? Is it routine maintenance? Is it construction? And notice that, a project can be routine maintenance. Some maintenance is a project for sure. Changing out a sink, or maybe, just relocating people up and down the hallway could be considered a project for sure. The location of the project, again, this is a big deal. The one thing we're held to right now is we need to know the patients that are in the area and the patients that may be potentially affected by it. And it's never enough just to know the ones in the area. It's always important to know the ones around the area as well, because again, air moves inward or outward, and upward or downward. And so that matter, you got to know who's up, down, left, and right. So who's around the area in which the work is going on. Again, developing a master phasing plan. And this is so critical because I think there is a misconception that ICRAs are one and done. However, unfortunately, during projects, they go through phases, and each phase is different, and the ICRA could be different for each phase. And you could require a ICRA for each phase. You could actually have a different ICRA each time. I know that we tend to want to do one comprehensive ICRA. I absolutely felt that way, and you try to do it if you could. But if so lots of times you just couldn't do it. The projects were just too specific. Or maybe one piece of the project was so ICRA intensive that you didn't want to have to apply that intensity throughout the project. So in some respects, it can actually help you not have to put in such intense ICRA if only one piece of it is going to be intense, thus saving you some time and money. What type of patient is adjacent? We talked about that just a moment ago. And again, the duration. Very, very important duration. The biggest thing with duration, we'll talk about it some more a little bit later, is the fact that, when you build a wall or you build a barrier, because it is temporary, it changes. And because work is going on, there are often impacts, and I mean physical impacts, to that wall or to that barrier that change during the duration. I have seen many examples of long-term projects where the barriers have deteriorated significantly because of time and because of the intensity of the work. Again, what is the patient risk group in and around the area? We talked about that. And will there be interruptions to the MEPS, which is not really necessarily tied to ICRA, although it is, especially when it comes to water. And I suppose air as well, yeah, because if you're going to stop the airflow for some reason, or if you're going to, when things surge, humidity changes, temperature changes can certainly be involved with ICRA. Think about, what happens if you have an interruption to a air handler, and that air handler feeds some supply rooms, and that supply room has some clean supplies. They have to maintain a specific temperature and humidity, and you're only off for 6 hours or whatever, but it's really hot outside, and that humidity changes and the temperature changes. Again, those are the kind of things we don't necessarily think about, but temporary interruptions can absolutely affect our infection control situation. Again, we're also going to talk a little about hazardous materials assessment. This is something we sometimes miss. Regulated materials that may be present. This is one that often bites us sometimes, where we're into a project, and for reasons, and there are many, that we just simply forget that we might run into hazardous material. And there are various types. We often think of asbestos, and asbestos is a common issue, and it's something we run into, and it sometimes surprises us. For most people, it's not a surprise. You either know that you don't have it, or if you do have it, you have a plan in place that tells you where it is. But there are other things like PCBs, lead paint, mercury, hazardous chemicals. That's an interesting one. We miss that we have certain hazardous chemicals in the space, and we don't realize how they interact with one another, or how we have to store them or move them or whatever else. Again, understand the materials that are present within your space before contractor or hospital staff swing the hammer. And I think that's the critical thing, is you need to know this ahead of time. Nothing worse than getting into the middle of a project and then running into the stuff, and everything comes to a screeching halt. And next thing you know, you find out you're going to have a very long delay, or a very urgent, expensive assessment or remediation taking place that nobody planned for. Never, never a good thing. The ICRA itself, again, the ICRA Infection Control Risk Assessment, which we have studied before, but we want to just, again, review again and again. And we're not going to talk about PICRA right now, and really we should, a proactive risk assessment or pre-construction risk assessment. The ICRA is still the meat of it. And, communication in the early stages of a project plan between all parties is crucial. Sometimes we don't realize just how many different people might be involved in the planning phase. There should be a drawing that's created for the phasing. This will allow us to have kind of a clear picture of what needs to be done in the beginning and some of the implications of that picture. It also helps us to translate that information to the contractors that are coming in. Again, all projects have a potential of risk. It is important to identify up front and take these steps to keep the patient safe. Like any other project consideration, planning is the key to success. The old adage, those who fail to plan to fail. And that's when it comes to ICRA, this is becoming much, much more of a critical issue. So one thing that will really help you when it comes to infection control risk assessments and ICRAs is actually having a proactive infection control floor plan. If you know very specifically how your building is laid out, what patient populations you have, what kind of physical building populations you have, and you can lay that out. Again, here's a good example of one where in red you have high risk, and in kind of that bluish color, I'm sorry, red is highest risk. The blue color is a high risk, and that sort of purple color is a medium risk, and then everything in white is a low risk. And again, if you can lay this out proactively, it'll help you work through and communicate the implications of folks in the building. Again, I know we've talked about public and we talked about employees, and maybe your documents can be that sensitive. Again, that's not likely. So you have to deal with the populations you have, and that's a good foundation to start working through assessments with people who are not familiar, with your facility. Again, this is not an expectation, this is not a requirement, but it's absolutely a good idea. So, construction area zingers, and we touched on some of this. We'll touch on it again. Temporary barriers, are they effective or ineffective? I still believe there are a number of people that have completely very wide opinions on what a barrier should be and what it should look like. How far should they extend? Do they need to be rated? What else do they need to be? This is a big deal. I mean, we can come into the same project and have 3 different ideals or 4 different ideals of what needs to be done when it comes to barriers. Again, negative air, do you measure it? Do you monitor it? I mean, it's one thing to measure it when you first do it and say, hey, yeah, we're pulling great negative pressure, but then again, will that change due to environmental condition changes, or what happens if someone, opens up a wall for some reason and it changes it? Or maybe they, take out some kind of a air conditioning unit that's on the wall based and changes it, or they leave the doors open, or something like that. Again, does it need to be continuously monitored? And that's another great question. Do you use a passive monitor, which is just like a ping pong ball that someone sees and looks at every so often during the day? Or do you have an active monitor that's actually monitoring with an alarm and with numbers and recording. We'll talk about that some more again too. But this is a big deal. It's not just a simple one and done. Waste load is also another major situation. Do we have a path for plan for egress? Is it going to go out the window, or is it going to go out through the building? If it goes out through the building, are the corridor paths clean? Is there dust, debris, and footprints in the elevator? Are stairwell doors propped open? Is it covered? Does it need to be sprayed and wetted down? There's all kinds of considerations when it comes to waste. Communication. Do workers and staff understand importance? And did you ask them? Again, do workers and staff understand importance? So many times we educate supervisors or job site supervisors, and they bring in 3, 4, 5, 6, 7, 8, 9 contractors or subcontractors. Does that get passed along? Is it worth going around and when they come in, asking them questions and recording your results? It would be interesting if you made it a practice that when a new contractor or sub comes on site, you just naturally go out there and ask them 2 or 3 questions related to infection prevention, and then you report that data back to the contractor, and say, hey, listen, you're doing a great job. You had 5 different subcontractors. I talked to them, and they all knew all 3 answers. Or for that matter, listen, I talked to 5 subcontractors, and no one had a clue what I was talking about. So you can see where that could help you improve processes and really help develop, if you will, your contractor group as being the A team that you want in your building versus the C, D, or E team that you're concerned about what they might do next. Again, and then right along that is training. There needs to be something that documents training for the contractors before. They need to have awareness. There are several training products out there right now that people can take. Obviously related to this program is a product called CHT, Certified Healthcare Technician, online program. Take the 3 hours of program online at their own convenience. Get a certificate at the end. Renew it every 3 years to stay current. Again, that's something that you could put into play that could help establish a baseline that the people that came on site have at least awareness. Again, did they sign in? Make sure you have their names documented that they were there at the training. Distributing minutes, that's something a little different. That's kind of like feedback to make sure that what you thought was expressed and heard, that people have a chance to look at it and validate, yes, that is what was said and what was heard. When it comes to barrier erections, it's important to choose the correct barrier for the project. Again, I'm not going to say a whole lot about this. Anymore, solid barrier seems to be almost becoming the status quo for any project that's definitely level 3 or level 4. When it comes to construction infection scoring, you can use softer barriers on level 1. Well, you don't really need them for level 1, but level 2 type construction. Got to take into account, of course, duration because of what's going on, and not just because of the type of construction, but sometimes noise is an issue, vibration is an issue, even sight can be an issue. There are times where you do not want people to see what's going on that could cause them to become uneasy or feel nervous or concerned. Again, a rated wall, very important that if you put in a temporary barrier wall because you've taken off a wall, it has to, if it's a rated wall, it has to be to the same rated assembly, or you're going to be into some possibly very serious infection, interim life safety situations. Again, ensuring that barriers are airtight and constructed material of limited flammability. This is another thing we sometimes miss. It has to be fire rated poly. It just can't be poly we bought down at the local hardware store. Holding staff and contractors accountable. We talked about that, about maintaining it. This is a big deal. It unfortunately, for extended duration projects, it often deteriorates. There needs to be some action, interaction, and feedback that things are getting done. It's actually, candidly, a very good thing to document problems and then show that they were taken care of, because it shows an intentional nature. Unfortunately, too many times when we do inspections, throughout a whole project, they all come back clean, like nothing ever went wrong, and that's really just not reality. I mean, and it's not that we don't want to be, quote, perfect, but it's not, in my opinion, it shouldn't, it really, we're not perfect and we make mistakes, and it's really how you respond and how you recover and how you address mistakes that's really what's important. And demonstrating that, I think, is very important. Again, many times, this is the only barrier between an active construction site and a patient-occupied setting. So, you have to make sure that those barriers, especially when it's in that situation where it is the only thing between the construction and the patient. And I saw a very large project like this recently where there was so much traffic and activity going on the other side of a wall. In fact, it wasn't just on the other side of the wall. The whole wall was taken out, and it was a rated wall. And not only that, but the wall was taken out to the deck, but there was a ceiling where the patients were trafficking that had to be covered with a plastic to seal it, because the space above it, the plenum space above it, was open to the construction site. And so you could see a very significant potential for contamination to be coming down above the patients through, holes where lights were, or through sprinkler head, if there was a sprinkler head escutcheon plate missing, or if a tile was broken or whatever. It could be a very serious way for that construction dirt and dust and air to be pushed through above the ceiling. So again, it's one of those things where you really have to understand that there's a very thin line of margin of protection for the patient sometimes during construction. Here's a couple examples. You can see here over to the left, there's a nice solid hard wall going down the hallway. Again, maintaining, if you count those tiles there, I think it's about a 5-foot, space down the hallway, which is nice. We have like lots of 4-foot minimums. Off to the right, you can see that overlapped plastic going into that space to the right, where it's creating, a plastic barrier into that room to the right. Here is a bad ICRAs. This was a common practice and still is. We got those. I remember years ago when we got them, those little extending poles in plastic. We were like, yay, we have a quick answer, to do these jobs. And I cannot begin to tell you how ineffective that really was, primarily because we just couldn't tape and seal it right. The other thing about this too is you can pretty much kind of see through this plastic. I doubt this is the right rated plastic or poly for the work. Over to the right, there's that, you can see inside that vent, someone has stuck a filter, a little pre-filter, probably like a 80% filter even, into an active space as a way of trying to filter dirt and air. Again, seems like a good idea at the time, but you can also see it's not very effectively even holding. And then down below, there's a stairwell usage as storage. Again, it's just too common practice to use what's available to you. And because stairwells sometimes have just a nice, great, big landing space, and it seems like a space where there is space to put stuff, it could be real common for people to just kind of just say, hey, just go put it there. And then you can even see in that space where the storage equipment is that someone coming down those steps in an emergency, or if you had a bunch of people coming out, this is going to cause one bad situation. Again, soft barriers are common. There are good ways to do these things, and we can use soft barriers, but boy, it takes a lot more work. You can even see in this one here, where that closer picture to the right, there's the gap. There's obviously air going up and out. Like I was telling you before, elevators, what do? They move, and what do? They displace air. So there's no doubt that as elevators are traveling up and down this shaft, air is being forced out of the elevator shaft into the space, and depending upon what they're doing inside that space, this could be a serious ICRA situation. A couple good examples of hard barriers. Again, nice solid walls, drywalled in, undamaged barriers. These are obviously brand new. I think the one upper left with the plastic, I'm not sure how long that's going to last, depending on what's going up and down that corridor. And then the old portable pop-up tent plenum. A lot of us have gotten these over the years. These are good. There's nothing wrong with these. It's just utilization. They're not convenient. Obviously, when you're inside of them, it's not very comfortable. Space is tight. Zipping yourself in, zipping yourself out. It's just this is not convenience at all. You can even see, if you look at the top, some of the things you have to avoid. There's a speaker. There's a exit sign. There's looks like some kind of maybe antenna maybe. And then there's that little half bulb or glass or plastic mirrored bulb for trafficking. These things, unfortunately, there's just sometimes you got to squeeze them into the right space, and so not for every situation, but very common for most situations. One thing you don't see with this particular one, and it may not have been required at all, and that is the HEPA filter working on the outside. So, but they're more and more. I think this technology is improving, and as we get to the end, we'll even be talking about emerging technologies that go beyond minimums. Well, debris removal. We talked about this and covered again. We got to plan a route ahead of time, keeping away from the highest risk patient areas. Again, that's a very important thing. Where are the patients? How can we keep away from them? That should be where we start. Are we going to be using the same elevators and sharing elevators with patients or with food or with supplies? We certainly have to cover carts and sometimes wet down the material. We need to really wipe them and vacuum them. Too many times carts go in and out of construction projects and they're just filthy dirty. And we may cover, it's kind of funny, you have a cart and you have it covered up, the debris that's inside of it, but the cart itself looks like debris because it's just covered with dust. Dedicated hand off team. Interesting concept, that you keep people separated. When people come out of projects, they are often very dirty, and they can track material all over. You can only imagine if you were able to sit there and put some kind of a tracking material on contractors and then let them travel around the hospital and have some way to follow them where they've been. I mean, no doubt contractors go all over. They definitely hit the cafeterias. They definitely go in and out of departments, in and out of construction sites. And so the potential for contamination and cross-contamination is pretty constant. Again, there's a statement here. Does the route require its own ICRA? Again, the emphasis is, the answer is yes, but it's really built into the ICRA. And what it is this needs to be a detailed plan. It's so common to sometimes miss that the debris in the space and the creation of dust and dirt in the space obviously is directly related to everything leaving the space. So you're basically extending your construction area wherever that debris is moving. So it's really kind of in its own regard another project as things travel through your facility. And a really bad example to the left of someone doing project work and not cleaning up as they go, or leaving debris for, I guess, someone else, or who knows. Looks like a tornado here. I'm sorry to report this is not a tornado, but it is just a bunch of work that someone tore it out, and I guess someone's going to clean it up. And this is just, you never want to see this. Over to the right, a much better project, cleaned up or hopefully being maintained throughout the project. There is a requirement to keep our areas clean, keep debris removed, and keep them as orderly and as tight as possible. It's always nice to have a trash chute and going to the exterior of the building. Again, as long as we have the considerations of who's traveling around that dumpster, who's traveling around that chute, where the intakes are related to the chute, what other windows may that chute pass by. While no one should ever open windows on the exterior of healthcare facilities due to the change it causes in pressurizations, it is unfortunately all too common, and so it is a consideration. Maintaining negative pressure is a big deal for us. It's a struggle because how do we know that the HEPA filters are functioning correctly? Equipment, we don't always, I think, sometimes know how much CFM is it pulling? Are the filters in good condition? Is the pump and is the fan motor working properly? These are things that I don't know how often we inspect our equipment. I would imagine that equipment has a PM cycle and a schedule that candidly, how often does that occur? Changing the secondary to protect the primary, that's one way to reduce cost and to help yourself, is to have always you replace the secondary filter more frequently, and that way you can use the very expensive primary HEPA filter for a much longer amount of time. Again, in the event of a portable tent is being used, at least one HEPA filter vacuum should be used to create negative air pressure before the thin grid is open. Again, how will it be monitored? We talked about that before. Set low limit pressure alarms. This is one that gets us in trouble. You know, these low limit pressure alarms. Best sometimes we can do is we can create a little delay for the alarm while doors open and things open. And it's one of those things you have to think through how you're going to do it and how you're going to respond. And if there is an alarm, how do you follow up and document the follow-up? Negative air pressure machines must be energized with GFCIs and maintained until the facility determines they can be removed. How will this affect the HVAC system outside the project? Very good question. Very often, you know, when we change, for example, let's say that we're going to block some returns or we're going to block some exhausts because we're trying to maintain or create a negative or positive pressure environment, mostly negative. When we do that, what's the net effect to the spaces around our construction space? Because we're going to create either more air or less air flowing or being exhausted by covering up you know, these returns and these vents. You know, I'm sure if you've driven down the road in your car and you got air blowing on you and you're one of those cars, the old school cars that doesn't have dual climate control, and you have single climate control, and you know, the air's coming out nice and cold on you and you're just like, well, that's too cold, but unfortunately it's just right for the person sitting next to you. And so what do? You know, you sit there and you close the vent on your side, and what happens? Boom, a lot more air on the other side. So, you know, these things, it's simple sort of, I guess, physics, and you know, we need to think about that when we're doing these projects. Again, establishing negative pressure, you got to do it per ICRA. Again, must be achieved before the first swing of the hammer. Negative air should be exhausted outside of the building if possible. I know there's lots of discussion, and there is code that allows us to use HEPA filters and recirculate in the building. But you must be very careful. There's a visual negative connotation to when we do that, so be very, very careful. Some people have suggested, you know, pushing it into a plenum so as not to make it an eyesight issue. Again, constant monitoring air is a must. And this is kind of an oxymoron in a way. Constant monitoring. What does the constant monitoring mean? Does it mean you have to buy some big, expensive, fancy electrical equipment that's going to sit there and create some kind of a record that you can monitor? Or does that mean that you're going to every hour or some periodic period do a check and have it checked off? I think constant today is still left to open interpretation. So therefore, you know, those regular checks. But if you're going to do regular checks in intervals, you should have some policy, procedure, or statement that indicates what you do, why you do it, and then make sure you do it. You can use additional recirculating air scrubbers, and it may be required depending upon how intense the project is. Again, negative air might be exhausted outside of the project space, but within the building per the ICRA, and we talked about that just a moment ago as it relates to recirculation and HEPA filters. Here's an example of using a PTAC. So basically you have an external cooling on the wall. You've taken the cooling unit out and you've used its opening to pump the air out of it. I mean, again, just a smart way to do it. You know, sometimes you don't want to quote, you can't go out a window, you can't go out a wall, but you might have a PTAC sitting there and you can remove it, and bada boom, bada bing, you're exhausting outside. Again, a little more expensive system here for monitoring. Strip chart record monitoring. This is, you know, maybe where we're going. I don't think we're there today. Certainly there are some spaces where this is probably would be required. You know, you can certainly say this is going to hold people to a higher level of accountability, and at the exact same time, you're going to have a higher level of accountability, and you can bet your bottom dollar this piece of equipment is going to need to be calibrated on a regular basis. And you're probably going to have to record that calibration and record the use of that specific one on your project, particularly if you have more than one in your facility that you're using. So that way, you know, if something goes out of calibration, you're going to know what projects did we use the one that's out of calibration on, so you can go back and, you know, use that for potential any issues that might potentially come up. Again, smoke testing, really common. I've also seen people with baby powder. These are very common things to use to check direction of air. Again, there's a lot of training that's going to need to go on when it comes to all of this. Again, you got to conduct initial infection control training meetings with in-house staff, all contractors. You got to do daily project ICRA safety huddles and inspections. And then, a more in-depth annual ICRA training for in-house staff and contractors would definitely be well to have that documented. I don't believe there's a require for annual training for any of this, but if you have a policy or procedure, the way I looked at it, if you had people that didn't do ICRA very often, you train them more. If you have people who do ICRA all the time, and you can monitor their competency that they do it well, then you can extend the training. Why train someone how to drive a car if they drive a car all the time versus, maybe you should give someone a refresher if they haven't driven in 3 years. Again, or they might drive, so you want to keep them up to date. I mean, kind of a poor illustration, but I think you get the general idea. Again, be the patient. Really try to look at it from the patient's perspective. Think of yourself as being immunocompromised. Try not to think of yourself, them being like you. Unrelated but related. I know I often had trouble myself with flu shots. I know my staff struggled with getting flu shots for years. We were generally healthy people, didn't know why we needed flu shots until I changed the conversation and said it's not about you. It's about you, about us protecting the patient who's sick. It's really not about us. And it's kind of funny how that just clicked. It was like, oh, then I never had problems again. And I didn't have problems either. It's like, okay, I'm doing this to protect the patient. I'm not doing this because of me. And it was pretty easy to go get your flu shot. Same thing when it comes to infection prevention. If you put yourself in the idea of protecting the patient, being the patient, then it's much easier for you to look at the world a little differently. And maybe, your intentionalness and your activities will be much, much, much more specific. Okay. And of course, this is often said. I sometimes think this is a little bit overused. Would you conduct construction activities? The loved one was on the other side of the temporary construction barrier wall. I think we have a tendency to. I've heard this so many times over the years. It's true. It's true, but I don't want it to lose its value by I guess spending too much time on it. Let's talk shortly about hazardous material because it does tie in. And again, this is expanding. I'm going to talk about a little bit on hazardous material, but I also want to make sure to let you know that when it comes to infection prevention or ICRA, it goes well beyond even where we are today. This is a growing conversation. Asbestos, the one thing about asbestos, you cannot identify it by looking at it. If you were to look at this, you just really wouldn't know. You see a spray. Is that asbestos? Is that not asbestos? Again, there's no way to really know. If it is, and that's just the short of it. Typically, unless you absolutely have some kind of a comprehensive plan for your building, management plan, you really can't. And again, especially when you have an older building such as this, you have several areas of concern. It could be the insulation on the pipes. Again, it could be that fireproofing, which is really common back in the day. Was fireproofing was asbestos up until the early 70s, and then mid 70s, late 70s, early 80s is when it really was phased out almost in its entirety. Some people will say 1982, 1985, but there are exceptions. This is not just possibly an asbestos issue. For those of you who don't know, this is actually an life safety issue or a life safety issue, specifically that steel is uncovered. Just remember, some folks may remember that in 9/11, the fireproofing got blown off the steel when that plane hit, and the fire that ensued melted the steel, causing the collapse. And again, they largely blamed the missing fireproofing for that the towers coming down. And so this is a life safety issue as well as possibly someone who actually might have been. Imagine the person that might have been knocking off this asbestos to make space for it, not realizing that they were disturbing asbestos, putting it in the air, and possibly infecting themselves with potential future mesothelioma. Here's a good example of bagging and someone doing. You can see the container up there where he's spraying. He has a respirator on. The individual has bags all over the place. They're wrapped the pipe. The pipe is wrapped and they're just going around, wetting, taking off, putting into a bag, wetting, taking off, putting in a bag. Very slow, methodical process. You can imagine how long it took to phase this and set this up to go around and remove asbestos. But this is a common method for removing asbestos. And there's training for folks for small removal, for operations, where you can remove small pieces, because we have to have some training to remove small sections of asbestos, several, maybe a couple linear feet, as it relates to maintenance and operations procedures, or as it relates to an emergency situation. It's always important that if you have asbestos, you have people trained on site, because you can't really wait to bring someone on site, and you do want your people trained to interact with it safely. We often forget that we have years and years of tile in our facilities, and not just the tile but the mastic. Which layer might have asbestos. Again, you may be looking at tile at the top and say, hey, that's newer tile. It was installed within the last 10 or 15 years, and then come to find out you have tile underneath it that's 30, 40, 50 years old, and then you have mastic underneath that also may have asbestos in it, which was not too uncommon. So be careful when it comes to tile. How many layers do you have? Note too that when it comes to asbestos removal, you have to have basically not just you got to have basically your anti-space, where you can transition. It's never good enough just to have one barrier going into a hazardous material area. You often need multiple areas, so you can basically go from pretty much hot to warm to cool, or dirty to not so dirty to clean. Something that we have to really be careful of when we're doing any kind of hazardous material work. So, what is an asbestos O&M survey versus an asbestos project specific survey? And very important, an O&M survey is a comprehensive survey. It has to be conducted for buildings prior to 1985. There are some exceptions, for example, in Texas and some other places when there was hurricanes later than that, and they had to get a bunch of construction material, and it came from China, I believe, or overseas, and it had asbestos in it. They found out later. They now have material with newer buildings with asbestos, but for most places, it's pre-1985. You need to have an O&M survey of your building for lead and asbestos and other hazardous material. This is a comprehensive survey. They go and they sample all over the place, and they build you a drawing and a map, and they let you know, okay, that's a comprehensive survey, so you generally know what you have throughout your building. Project specific is just that. It's the site only. So maybe you don't have a comprehensive plan. Maybe you're working with an outside building. Maybe you've acquired an outside building and you're making modifications, and you just want to do just that specific area that you're going to renovate or you're going to disturb. Again, this might be required for any construction area. In some places, regardless of age of the building, it depends on your authority having jurisdiction and your building code. But know that there's difference, and you may hear both of these this language in the healthcare facilities profession. So, things are changing. Like I said, we've talked about minimums up to this point. I just wanted to show and talk a short moment about moving beyond ICRA Class 3 and Class 4 standards. What we have here is we have technologies that are emerging because of where the industry is going that really takes things to a very, very, very different level. You look down below left and you'll see some current type infection control practices, and nothing wrong with these. They are the minimums. But then you go to the upper right and you'll see something that looks very unusual. Look at this door. That is sealed, it covers, it's temporary, and it's solid, and for that matter, maybe possibly even rated. And what it does is it really allows you to create a much more consistent, reliable, long-term entry point and barrier point for a construction project. One again looks a little different, a little fancier, but these are different type of if you will, barriers that you can put up quickly and create an ante-room. Allows you to create something that doesn't go out into the hallway, lays flat against the wall, so you're not reducing your 8 feet. In this center picture, you can look there, you see all that stuff they have stored down the left side of that hallway, barely maintaining the 4 feet. What if you had to build some kind of a barrier coming out, 2 feet well, that's just not going to be acceptable. And where is all this stuff going to go? So, people are coming up with new solutions. This is going to continue to evolve. So keep your eye out. Keep asking questions. Keep coming up with ideas on better ways to do and go beyond the minimums.